Imagine you're standing on a primitive Earth, billions of years ago.
Oh, wow.
It's not the peaceful blue planet we know today, though. It's a golden world.
Really?
Yeah.
Yeah.
And it's constantly being bombarded by asteroids and planetoids.
Yikes.
It's chaos, like a cosmic demolition derby where planets are basically billiard balls smashing into each other.
That's a pretty intense picture.
Well, welcome to Cosmos in a Pod, the Space and Astronomy series. Please like, comment, share, and subscribe. Today we're diving deep into the solar system's wild past.
Exciting.
We're going to explore how those giant impacts shape the planets and moons we see today.
Those collisions weren't just fender benders. We're talking impacts so powerful they could shatter planets, tilt them on their axes, even create entire moons.
So let's start at the very beginning. What was the early solar system like?
Well, picture this. A swirling disk of gas and dust left over from the sun's formation.
Okay, I can see it.
Over millions of years, gravity pulled those particles together, forming bigger and bigger clumps.
Like a snowball effect.
Exactly. These clumps became planetary embryos, some the size of our moon, others as big as Mars.
So those embryos were the building blocks of the planets.
Precisely. But the solar system was a crowded place. These embryos were constantly moving around, colliding with each other. It was a chaotic dance, and collisions were inevitable.
And I'm guessing those collisions weren't exactly gentle.
Definitely not. Picture two planetary embryos, each traveling at tens of thousands of kilometers per hour, smashing into each other.
Wow.
The energy released would be unimaginable. It would melt rock, vaporize oceans, and fling debris into space.
Sounds more like a science fiction movie than reality.
It does, but it's how our solar system formed, and these impacts were crucial in shaping the planets.
So the inner solar system, with Mercury, Venus, Earth, and Mars, was especially chaotic.
Exactly, and that chaos led to the formation of the moon, the most familiar object in our night sky.
It's hard to believe the moon, with its gentle light, is a result of a cataclysmic event.
It is, but the evidence points to a giant impact. Picture a young, molten Earth being struck by a Mars-sized protoplanet named Theia.
Theia, like the mother of the moon goddess in Greek mythology.
Precisely. The name is fitting because this impact, about 4.5 billion years ago, was a head-on collision that changed Earth forever.
Wow.
The impact was so powerful that it ejected a massive amount of molten rock and debris into orbit around Earth, forming a ring.
And from that ring, the moon was born.
Exactly. Over time, gravity pulled the debris together, it cooled and solidified, and eventually it formed the moon we see today.
So a single event, billions of years ago, had a huge impact on our planet.
It did. It affected the length of our day and the stability of our climate, to name a few.
Incredible. It shows how interconnected everything is in the universe.
It really does. And speaking of interconnectedness, let's move on to Mercury.
Mercury, the smallest planet and the closest to the sun. What makes its story so unique?
Well, Mercury is an oddball. It's incredibly dense for its size. Its iron core makes up about 85% of its volume. That's much larger than any other planet.
So what explains that oversized iron core?
The leading theory is that Mercury wasn't always this small. It was once much larger, maybe twice its current size.
Okay.
But then, early in its history, it experienced a catastrophic impact. Imagine a massive object slamming into Mercury and stripping away its outer layers.
So Mercury was essentially left with just its core and a thin crust.
That's right. It's a shell of its former self.
It makes you wonder what Mercury could have been like if it hadn't suffered that impact.
It's a fascinating thought. But the story of impacts doesn't stop there. The inner solar system went through an even more chaotic period.
You mean a time when asteroids were raining down on the planets?
Exactly. And it all started with the ice giants, Neptune and Uranus, as they moved through the early solar system.
So they caused problems for the inner solar system.
You could say that. This period, called the Late Heavy Bombardment, saw a huge increase in asteroids hurtling towards the inner planets, including Mercury. It was a time of constant bombardment.
And Mercury, being the closest to the sun, probably took the biggest hit.
Absolutely. Imagine standing on Mercury during that time. The sky would be filled with asteroids. Impacts would shake the planet to its core. One of the most impressive scars from this period is the Caloris Basin, a massive crater over 1,500 kilometers wide.
1,500 kilometers, that's huge.
It gives you an idea of the scale of those impacts. And the impact that formed Caloris was so powerful that it created a jumbled terrain on the opposite side of Mercury.
It's like a cosmic battlefield.
That's a great way to put it. And speaking of battlefields, let's talk about Uranus.
Uranus, the ice giant that's tilted on its side. What could cause that?
Another giant impact, but this one knocked Uranus over. Picture a massive object, maybe an icy super-Earth, slamming into Uranus billions of years ago.
So it's like Uranus was in a cosmic T-bone collision.
It was an event of unimaginable scale. But unlike Earth, Uranus didn't gain a large moon from the impact.
Really?
Yeah, the impactor probably shattered within Uranus's atmosphere. Instead, Uranus ended up with a unique system of rings and moons, all orbiting on the same tilted plane as the planet.
So we've seen some dramatic impacts. From a moon-forming collision to a planet tilting one. What else is there?
Well, let's head to the outer solar system, to Pluto.
Pluto, the dwarf planet that captured our hearts.
Yes, and one of Pluto's most captivating features is Sputnik Planitia, a vast heart-shaped nitrogen glacier.
Pluto's heart of ice. How did that form?
Another giant impact, of course. Scientists think that billions of years ago, a large object struck Pluto, creating a basin that filled with nitrogen ice and became Sputnik Planitia.
So Pluto's heart is actually a scar from a collision.
Exactly. And there's more. Underneath that icy heart, Pluto might have a subsurface ocean.
An ocean on Pluto. That seems impossible.
It might sound strange, but there's evidence. One clue is Pluto's wobble, its true polar wander.
Pluto wobble.
Yes. It suggests a large mass beneath the surface, dense enough to shift Pluto's balance. And that dense mass could be a subsurface ocean. Liquid water is denser than ice, so it could cause Pluto to reorient itself.
Wow, I never knew that.
And there's more. The presence of ammonia in Pluto's system is another clue.
Ammonia, like the cleaning product.
Yes. It acts as an antifreeze, allowing water to stay liquid at very low temperatures. So even though Pluto is freezing, the ammonia might be keeping the ocean from freezing solid.
That's amazing. It's like Pluto's moon, Sharon, is helping to keep its heart warm.
That's a poetic way to put it. And this ocean on Pluto changes our understanding of where liquid water and maybe even life might exist.
It opens up a whole new frontier of exploration.
It does. These hidden oceans beneath the ice could be protecting life from the harsh conditions of space.
So the solar system is full of surprises.
Absolutely. We should never underestimate the power of nature. And speaking of surprises, let's go back to the inner solar system to explore Mars.
Mars. What surprises does the red planet have in store for us?
Well, Mars has a fascinating impact history, too. And one impact in particular stands out.
I'm ready. Tell me more. So before the break, we were talking about that hidden ocean under Pluto's surface.
Yeah, an ocean on a world so far from the sun. It's pretty amazing to think about.
It really makes you rethink where we might find the ingredients for life, huh?
It does. And the evidence for that ocean is strong, too. You remember how we talked about Pluto wobbling?
You mean that true polar wander thing?
Exactly. Pluto seems to reorient itself over time, and that suggests there's something massive under the surface, something dense enough to throw Pluto off balance.
And you're saying that dense mass is probably the ocean.
Right. Liquid water is denser than ice. So a big subsurface ocean could be pulling on Pluto gravitationally and making it reorient itself. That's what we're seeing with that true polar wander.
Wow, it's crazy how something we can't even see can affect a whole planet.
It really shows how everything's connected, even in space. And the wobble isn't the only clue either. We've also found ammonia in Pluto's system.
Ammonia? Like the stuff in cleaning products. What does that have to do with an ocean?
Well, ammonia works as an antifreeze. It keeps water liquid even at really low temperatures.
Ah, I get it. So even though it's super cold on Pluto, the ammonia could be preventing the ocean from freezing solid.
Exactly. Nature finds some pretty clever ways to keep water liquid even in the most extreme places.
It makes you wonder what's in that ocean. Is it just water, or is it more like a salty brine? Maybe it even has organic molecules.
Scientists are trying to figure that out. Based on what we got from the New Horizons mission, we think it's probably very salty, maybe even saltier than Earth's oceans.
A salty ocean on Pluto. It's like something out of science fiction.
It is pretty wild. But let's zoom out for a second and think about what this means for the solar system as a whole.
Okay, so what does Pluto's ocean tell us about the bigger picture?
It really changes our understanding of where water and maybe even life could exist. We used to think that liquid water was limited to the inner solar system.
Yeah, like Earth and Mars?
Right. But Pluto shows us that water might be much more common, even in the outer solar system, where it's super cold.
So maybe there are more oceans out there just waiting to be found.
It's a whole new frontier, and those oceans, hidden under the ice, might be protecting life from the harsh radiation and freezing temperatures of space. It's like the ice is a shield.
A cosmic incubator.
Exactly. Those hidden oceans could be full of life, evolving in ways we can't even imagine.
It's an incredible thought.
Nature is always full of surprises. And speaking of surprises, let's go back to the inner solar system and look at Mars.
Mars. What surprises does the red planet have?
Mars has had a really interesting history with impacts, too. And there's one impact that really stands out.
Okay, I'm all ears. Tell me about it. Okay, so before the break, we were talking about those giant impacts on Mars.
Yeah, Mars has had a wild ride when it comes to impacts. And one of the most impressive scars is Hellas Planitia, this huge impact basin in the southern highlands.
Hellas Planitia. That's one of the biggest impact craters in the solar system, right?
It is. It's massive, over 2,300 kilometers across, and it's 8 kilometers deep.
8 kilometers. That's like, what, almost twice as deep as the Grand Canyon?
It gives you a sense of just how powerful these impacts were. The thing that hit Mars to make a crater that big must have been enormous, probably hundreds of kilometers wide.
It's almost impossible to imagine the kind of energy released by an impact like that.
It must have been a truly planet-shaking event. And Hellas Planitia isn't just a cool feature to look at. It might also tell us something about what Mars was like a long time ago.
What do you mean? What can a crater tell us about the past?
Well, scientists think that Hellas Planitia might have once been a giant lake, maybe even an ocean. The basin is really deep, and there are signs of ancient shorelines.
So you're saying that Mars, even though it's dry and dusty now, might have had huge amounts of liquid water billions of years ago.
That's the idea. It's pretty exciting to think about. And the impacts on Mars didn't stop billions of years ago either. There's evidence of much more recent ones, even within human history.
Wait, recent impacts? You mean like since humans have been around?
Exactly. In 2018, a NASA orbiter spotted a brand new impact crater in Valles Marineris, that enormous canyon system on Mars.
So Mars is still getting hit by space rocks today.
It is. Not as often as in the past, thankfully. But it's a reminder that our solar system is constantly changing and things can happen out there that we need to be aware of.
It's a little scary, but also really cool to think about. It makes you realize how important it is to explore space and understand what's happening out there.
Exactly. And by studying the impact history of planets like Mars, we get a better understanding of what shaped our solar system.
We've seen how impacts have created moons, tilted planets, and maybe even created environments where life could exist. It's been an amazing journey.
It really shows you the power of these cosmic events.
Well, that's all the time we have for today's deep dive into the solar system's wild past.
Don't forget to subscribe to Cosmos in a Pod and check out our YouTube channel for more cosmic adventures.
Keep looking up at the night sky and wondering about what's out there. Until next time.